While solving by graphing is ideal if the graph is already given or they're very easy equations to graph, sometimes it's not as easy to tell where the point of intersection is if a graph is hand-drawn. In that case, it's possible to use a method called substitution. In the method of substitution, there are several steps to follow. You want to solve one of the equation for one of the variables. You can decide which one's easiest, and it doesn't matter which one you use. Secondly, you're going to substitute that new expression you've solved into the other equation. This equation that you've now substituted into, you will solve for the now single variable. And then once you have that value, you'll plug it back into one of the original equations to find the missing variable. Again, it's important to check both equations to ensure that the solution works. Let's begin with an example here where we're going to solve this system. We can choose to solve for either variable. I'm going to choose to solve this equation for y. To do that, I'm going to subtract x from both sides, resulting in y equals 6 minus x. Now that I have a value for y, I can take that and substitute it into my second equation. Rewriting the second equation now, I have negative 2x plus, I have now for y, 6 minus x equals 0. I only have one variable now, and I can simplify this equation to get negative 2x plus 6 minus x equals 0. Combining like terms, I get negative 3x plus 6 equals 0. Subtracting 6 from both sides, negative 3x equals negative 6, or x equals 2. Remember, to get the solution to a system, we're looking to find the ordered pair that works in both equations. X is only one part of that ordered pair, so I need to go back to either one of my equations. I'm going to choose this one and plug in the new x value of 2 that I've calculated. Into x plus y equals 6, I will plug in 2 plus y equals 6, giving me a value of y equal to 4. I therefore have an ordered pair of 2, 4 for my solution, which I can plug into the original equations and check. Using x plus y equals 6, I plug in 2 plus 4, and it does equal 6. In the second equation, I can plug in negative 2x plus y equals 0. Negative 2 times 2 plus y does give me 4, with a y value of 4 there as well. 2 times negative 2 is negative 4, plus 4 does indeed equal 0. To show you what some of our special cases look like, let's consider this system. Following the same steps, I'm going to choose to solve this equation for y. When I have 3x plus y equals 1, I will subtract 3x from both sides, and I get y is equal to 1 minus 3x. I can then substitute this value for y into my second equation, resulting in 6x plus 2 times 1 minus 3x equals 3. Combining like terms, I'm left with 6x plus 2 minus 6x equals 3. Notice here, when my like terms cancel, I'm left with 2 equals 3. This should feel strange because this is a statement we know can never be true. If this is the case, this means there is no solution. Please note that this would indicate these lines are parallel, and based on our understanding of slope that we've developed in other courses, we can see that the slope of these two lines is the same, indicating that the lines are parallel and there is no point of intersection.